Welcome to Hot Topics. In this video, we're going to talk about the difference between intrinsically safe systems and non-incendive systems. But before we get into the video, I would like to remind you, if you like these videos and you feel like they are beneficial to you, hit that subscribe button and tell your buddies and friends about it, that we do nothing but code related type videos. It would be, I believe, helpful to them if they want to watch all these videos that we're doing. And we're going to try to bring one each week to you. Right now, the staff, we're writing our illustrated code change book on the 2023 edition of the NEC. And with those messages, we'll get right into our video. Now, we're going to be looking at 16 illustrations. So I'm not going to go through the code and read each section. I'm going to let you do that on your own leisure time if you want to do so. But in dealing with intrinsically safe systems, there are 6 steps, as you see in the video, that needs to be taken, in my opinion. Number 1, we select our equipment in the NEC in Article 504 on page 386. The equipment, the enclosures, and the wiring methods, and so forth. We define the electrical equipment in the NEC in Article 100 on page 43. We select our wiring methods per NEC 504.20 on page 386. And we select our seals when necessary for these systems in NEC Article 504, Section 504.70 on page 387. Identification of the system and circuits and so forth is in the NEC in Section 504.80. And then finally, the grounding and bonding of the system and the circuits and the enclosures as well. NEC 504.50 for bonding on page 387 and 504.60 on grounding on page 387. Well, that may be vice versa there. 504.50 is grounding and 504.60 is bonding. Excuse me, I just got a little mixed up on that. Now, basically, you know, in the intrinsically safe system, we have a barrier. The barrier creates a safe zone of circuitry and wiring methods. And basically, the wiring methods could get damaged. Components could get damaged, maybe by driving a screwdriver through one of the components or whatever. And there wouldn't be an arc or a spark that would exceed the ignition temperature of the gas or vapor that we would select from NFPA 70E, table 5.4.2, which we really won't get into today. But if you wanted to really look at the barrier in more detail, go to UL 913. Also some information in UL 12.06.01 that you see in the illustration. Now, in the 2014 edition, 504.2 Informational Note 2 define intrinsically safe systems. Now it's Article 100, Part 3, page 45. And you'll find in the 2023 edition that all the definitions in the code now have been moved into Article 100 and the parts done away with. I always kind of like Part 1, 1,000 volts or less, Part 2, over 1,000 volts, and Part 3 when they added additional definitions to help us in classified areas. So this is our illustration 1 that we're looking at, and now we're going to illustration 2. Now, illustration 2, again, kind of defines these systems. And, of course, that's 504.2 in the 2014. The 2017 And the 2020 code, rearranged these definitions into Article 100. Now, the wiring methods that you're going to select would be 504.20, page 386, as you see in the illustration. And notice once you select these wiring methods, and the system has been listed and labeled for Class 1 Division 2, Class 1 Division 1, Class 2 Division 2, Class 3 Division 1 and 2. In other words, intrinsically safe can be used in any of the divisions, such as gas and vapor, dust, flyings, and fibers. These systems can be used when designed for such areas. And then notice in the note and the illustration, we refer you to NFPA 497 1.2.1. And if you wanted to look at the off-field information, production, refineries, and so forth, pipelines, go to the API 500, and you'd begin at 1.1.1 and 1.1.2. And they kind of refer you back, these sections, to the NEC to determine if we have a problem or not. Now, the hazardous locations in the NEC to really just serve as an aid to see if we have a problem. And if we do have a problem, we know we'll find that in 500.5b 1 and 2 on page 362 of the NEC. But we would have to go to NFPA 497 for gas and vapor, and NFPA 499 for dust, flyings, and fibers. Now, this illustration just points out what I just kind of went over with you. And again, it points out that the barrier is now, the information about the barrier can be found in UL 13 and UL 12.06.01. Now we're going to move to the third illustration that we want to look at, or figure. And we're dealing with the equipment. And NEC 504.4 on page 386 of the NEC, that you can look that up on in your time, your leisure of time. And then, of course, if we want to use general purpose enclosures, and we can, then we would look at 504.10c as outlined on page 386. Now notice a basic function and how the barrier provides this safe zone. Notice we have a Zener diode that's a voltage damper. It kind of clamps the voltage, lets it rise to the point it needs to rise to send the avalanche of current, that is current limiting by the resistor, to blow the fuse and protect the barrier in most all cases. And we know, if you get to looking back in the history of the NEC, intrinsically safe systems has been in the code since 1956, but they were identified as ITSC systems, which today they're just IS systems. So keep this in mind. And of course, you know the voltage is less than 50 if you look at the note 3. And it's usually about 18 to 30 volts DC is basically the operating voltage. Then again, the note 1, we send you to the UL standards to obtain more information about this Zener diode, current limiting resistor with fuses, and learn more about the barrier and more detailed information. Now with that, we'll go to note 4. And I shouldn't say note 4, but figure 4. And we're looking at location. And 504.10b on page 386. And you all field people, API 500, those sections that you see listed, will refer you over to the NEC to see if you have a problem or not. But the most important thing is to keep that barrier, if you can, and its enclosure in a non-classified area. Not over in the classified area where you'd have to use an explosion-proof enclosures, and that's where those seals, see, would become necessary on that supply side that you see there. And then the load side, naturally, you can choose your wiring methods from 504.20. Now, with that in mind, we're going to move to the next figure, which is 5. And we can place these intrinsically safe circuits in raceways, cable trays, and cables can be used in accordance with 504.30A1. And then, of course, you have your API references there that would send you to the NEC if you had a problem. If you had a cable tray, for example, you'd have the grounding in 392.60. And then, of course, the bonding 392.60B as in boy 4, 250.96, and 250.102. And then if you happen to have a copy of our electrical design book, you notice in the note we keep you going from page to page, figure to figure, until you get a complete circle made on just exactly what the code requires when you deal with intrinsically safe circuits. Now let's move to our next figure, and that'll be figure 6. And we're talking about with enclosures. 504.30A2 on page 387 if you look it up. And notice we need a separation of these intrinsically safe circuits of at least 2-inch separation in accordance with 504.30A2, or we could have the non-metallic barrier between them to separate them. But there is a separation required, as you see here, right above the caption within enclosures are call out intrinsically safe circuits, at least a 2-inch separation when you enter into enclosures. Now with that, let's move to our figure 7. And notice other not in raceway or cable tray systems. These rules are outlined in 504.30A3 on page 387. And they're saying these circuits, if you had power circuit and IS circuit, keep them separated at least 2 inches, or the cable needs a separating jacket or routed and conduit, but you do need a separation. So kind of keep that in mind, and that's what this figure is illustrating to you. Let's move now to our figure 8. And on our figure 8, or in our figure 8, identification. Now, identification begins in 504, and we pick up 504.80A and B at this point, and we're basically picking that up on page 387 and page 388. Now, notice we do have to have these identification of circuits. The notes is for terminals and wiring, see NEC 504.80A and B. Notice the label. The label has to be on the wiring method, the conduit, the cable tray. At least every 25 foot identification is required so that you know that this is an intrinsically safe circuit and don't be using it in any other manner. So the labeling is showed that we need that for every 25 foot to identify the system. And then, of course, you see the seal requirements are there, 504.70 and 501.15, 502.15, and 505.16 if we happen to be in the zones, which we're not covering the zones in detail. Now, the next figure that we look at is 9, and it deals now with color coding in accordance with NEC 504.80C that we would want to review there. Now, notice that in the note, it talks about raceways, cable trays, and cables containing intrinsically safe circuits shall be marked every 25 foot with a light blue color. Now we use the light blue again to distinguish these circuits from other circuits and don't mess with them without you have a reason to be there. Now we're going to move to our figure 10, and it deals with grounding. And notice that it's highly recommended, without it's a necessary thing, and then you have a lot of work to do if that be the case, that you don't ground to driven rods and those kind of items. You could ground to the structural steel that you see there. You could ground to a metal water pipe that is an electrode in accordance, with 250.52A1, or a concrete encased electrode could be used, or even a ground ring around the building. And they do this so that they like to have a 1 ohm reading where the wire connects to the grounding electrode. Not at the barrier now, but at the electrode, they like to have about a 1 ohm reading if possible. Now, we'll move over now and look at figure 11, and we deal with bonding. And notice it just basically states in 504.60A and B on page 287 that we have to bond from the intrinsically safe circuit equipment in the hazard zone or area back to the barrier, back to the computer, and then over to the computer readout board where you'd be reading or screen where you'd be reading certain things that the system was designed to read. So this is just bonding. And a lot of times people say, well, why in the world do we have to bond? It's intrinsically safe. Well, the reason for it is other voltage from other power sources and things that could get on it that is too high and could damage components and wiring on the system. Now, with that thought in mind, let's move to our figure 12. Now we're going to get into non-incendive. Now notice the non-incendive circuit, you don't have the barrier. And this is where people get mixed up. They'll go over to page 43, I think it is, 44 or 45, right in that area of Article 100. And they read the definition of intrinsic safe, and it includes non-incendive. The only thing, you have to go through the rest of the code and look at other sections and tie them together to understand that if that wiring is damaged in any way in a non-incendive circuit, or a component, you drive a screwdriver or something through a component and an arc develops, it's not the type of arc then that might not cause an explosion under certain conditions, see? So there's about 5 steps here. Look at the step 1. Select your equipment. 500.7F and H. And after you select your equipment, define your electrical equipment in Article 100. And basically, where these systems are used, they're used for meters, instruments, relays in accordance with 501.105B2, signaling, alarm, remote control, communication systems in accordance with 501.150B2. And then, of course, the 5th step is selecting your wiring methods from 501.10B3 for for non-incendive circuits. So that's going through steps 1 through 5. And in this figure 12, you notice now to define these systems in Article 100 is page 44. And then you define the circuits, the components, and the etc. And then you go to 500.7F, G, and H, and you select these components to be used in steps 3 and 4 for that type of equipment. So with that thought in your mind, let's move over now to figure 13. Now here we see the wiring methods to the left of the illustration. Wiring methods 501.10B3 on page 370. The non-incendive wiring, like in the oil industry and these refineries, they'll use tray cable. In other words, you can use any of the wiring methods that's in Chapter 3 in accordance with 501.10b3. And general purpose enclosures can be used in 501.105b2 on page 374 and 377 of the NEC. And also, if you have the Designing Electrical Systems by Stallcup, Volume 1, you can go to the Annex C and just read a lot more information about when you're installing non-incendive circuit. You have a roadmap there. You also have a roadmap for intrinsically safe that you could review. And then notice 500.2 in the NEC loop is now Article 100. And then you have your two major sections when you use non-incendive circuitry. 501.105b2, exceptions 2 and 3, or 501.150b1, exceptions 2 and 3. And if you're not using hermetically sealed contacts, you're not using all emerge type contacts, and you're using non-incendive when you visit this section 501.105 and 501.150 on page 374 and page 377. And notice general purpose enclosures and general purpose wiring methods may be used as outlined in those sections. Now let's move to figure 14, and then notice again, we're getting into recommended requirements, not required by NEC. Now keep that in mind, but it is suggested that when you have raceways, cable trays, cables and so forth, that they be identified every 25 feet so that you know they're different. The intrinsically safe circuits that are identified every 25 feet by a label are a blue color coding type system. Now notice seals are not required. Now let's go to our illustration 15 or figure 15, and notice we recommend light yellow color coding. So when you see yellow non-incendive circuits, you know they're different from the intrinsically safe circuit, as well as all the other power circuits that you may have. And so this is our recommended color coding. Now let's look at our final figure, 16. And notice we're looking at contacts that are hermetically sealed or emerged in all in accordance with 500.7i and j on page 364 of the NEC, and Article 100, page 43 and 44, they're defined. So notice we can use intrinsically safe circuitry in Class 1 Division 1. We can use non-incendive in Class 1 Division 2. And all emerged contacts, taking care of the contacts, they can be used also in accordance with 501.105b1, looking at the exception, that pertains to it on page 374 and 377. We would also pick up 501.150b and the exception that would deal with all emerged type. So here we have all emerged at the top of the illustration, hermetically sealed at the bottom, and notice all of these types of systems can be used in a Class 1 Division 2 location, but not a Class 1 Division 1. Now, what is the difference basically in intrinsically safe, or non-incendive? Is that we have a barrier that creates a safe zone where damaged wiring and components has no effect to cause an explosion. Where non-incendive must be used under normal operating conditions, no damage to wiring, and no damage to components. Now there you have it. And my name is James Gray Stallcup, and Thank you for watching this video.